Introduction. This guide will help both employers and employees do the following. Understand the types of PPE. Know the basics of conducting a hazard assessment of the workplace. Select appropriate PPE for a variety of circumstances. Understand what kind of training is needed in the proper use and care of PPE. The requirement for PPE. Performing a hazard assessment of the workplace to identify and control physical and health hazards. Identifying and providing appropriate PPE for employees. Training employees in the use and care of the PPE. Maintaining PPE, including replacing worn or damaged PPE. Periodically reviewing, updating and evaluating the effectiveness of the PPE program. In general, employees should properly wear PPE. Attend training sessions on PPE. Care for, clean and maintain PPE, and inform a supervisor of the need to repair or replace PPE. The hazard assessment. The hazard assessment should begin with a walkthrough survey of the facility to develop a list of potential hazards in the following basic hazard categories: impact, penetration, compression, rollover, chemical, heat, cold, harmful dust, light, optical, radiation, and biologic. In addition to noting the basic layout of the facility and reviewing any history of occupational illnesses or injuries, things to look for during the walkthrough survey include sources of electricity, sources of motion such as machines or processes where movement may exist that could result in an impact between personnel and equipment, sources of high temperatures that could result in burns, eye injuries or fire, types of chemicals used in the workplace, sources of harmful dusts, sources of light radiation, such as welding, brazing, cutting, furnaces, heat treating, high-intensity lights, etc. The potential for falling or dropping objects. Sharp objects that could poke, cut, stab or puncture. Biologic hazards such as blood or other potentially infected material. Selecting PPE. OSHA requires PPE to meet the following ANSI standards. Eye and face protection, ANSI Z87.1 1989, USA Standard for Occupational and Educational Eye and Face Protection. Head protection, ANSI Z89.1 1986. Foot protection, ANSI Z41.1 1991. Training employees in the proper use of PPE. Employers are required to train each employee who must use PPE. Employees must be trained to know at least the following. When PPE is necessary. What PPE is necessary. How to properly put on, take off, adjust and wear the PPE. The limitations of the PPE. Proper care, maintenance, useful life and disposal of PPE. Eye and face protection. Employees can be exposed to a large number of hazards that pose danger to their eyes and face. OSHA requires employers to ensure that employees have appropriate eye or face protection if they are exposed to eye or face hazards from flying particles, molten metal, liquid chemicals, acids or caustic liquids, chemical gases or vapors, potentially infected material or potentially harmful light radiation. Many occupational eye injuries occur because employees are not wearing any eye protection while others result from wearing improper or poorly fitting eye protection. Employers must be sure that their employees wear appropriate eye and face protection and that the selected form of protection is appropriate to the work being performed and properly fits each employee exposed to the hazard. Eye protection for exposed employees. Examples of potential eye or face injuries include dust, dirt, metal or wood chips entering the eye from activities such as chipping, grinding, sawing, hammering, the use of power tools or even strong wind forces. Chemical splashes from corrosive substances, hot liquids, solvents or other hazardous solutions. Objects swinging into the eye or face, such as tree limbs, chains, tools or ropes. Radiant energy from welding, harmful rays from the use of lasers or other radiant light, as well as heat, glare, sparks, splash. 10 and flying particles. Types of eye protection. Selecting the most suitable eye and face protection for employees should take into consideration the following elements. Ability to protect against specific workplace hazards. Should fit properly and be reasonably comfortable to wear. Should provide unrestricted vision and movement. Should be durable and cleanable. Should allow unrestricted functioning of any other required PPE. Safety spectacles. These protective eyeglasses have safety frames constructed of metal or plastic and impact-resistant lenses. Side shields are available on some models. Goggles. These are tight-fitting eye protection that completely cover the eyes, eye sockets and the facial area immediately surrounding the eyes and provide protection from impact, dust and splashes. Some goggles will fit over corrective lenses. Welding shields. Constructed of vulcanized fiber or fiberglass and fitted with a filtered lens, welding shields protect eyes from burns caused by infrared or intense radiant light. They also protect both the eyes and face from flying sparks, metal spatter and slag chips produced during welding, brazing, soldering and cutting operations. OSHA requires filter lenses to have a shade number appropriate to protect against the specific hazards of the work being performed in order to protect against harmful light radiation. Laser safety goggles. These specialty goggles protect against intense concentrations of light produced by lasers. The type of laser safety goggles an employer chooses will depend upon the equipment and operating conditions in the workplace. Face shields. Face shields protect against nuisance dusts and potential splashes or sprays of hazardous liquids but will not provide adequate protection against impact hazards. Face shields used in combination with goggles or safety spectacles will provide additional protection against impact hazards. Head protection. Protecting employees from potential head injuries is a key element of any safety program. A head injury can impair an employee for life or it can be fatal. Wearing a safety helmet or hard hat is one of the easiest ways to protect an employee's head from injury. Hard hats can protect employees from impact and penetration hazards as well as from electrical shock and burn hazards. Employers must ensure that their employees wear head protection if any of the following apply. Objects might fall from above and strike them on the head. They might bump their heads against fixed objects, such as exposed pipes or beams, or there is a possibility of accidental head contact with electrical hazards. Types of hard hats. Class A hard hats provide impact and penetration resistance along with limited voltage protection, up to 2,200 volts. Class B hard hats provide the highest level of protection against electrical hazards, with high voltage shock and burn protection, up to 20,000 volts. They also provide protection from impact and penetration hazards by flying, falling objects. Class C hard hats provide lighter weight comfort and impact protection but offer no protection from electrical hazards. Foot and leg protection. Employees who face possible foot or leg injuries from falling or rolling objects or from crushing or penetrating materials should wear protective footwear. Also, employees whose work involves exposure to hot substances or corrosive or poisonous materials must have protective gear to cover exposed body parts, including legs and feet. If an employee's feet may be exposed to electrical hazards, non-conductive footwear should be worn. On the other hand, workplace exposure to static electricity may necessitate the use of conductive footwear. Examples of situations in which an employee should wear foot and/or leg protection include when heavy objects such as barrels or tools might roll onto or fall on the employee's feet. Working with sharp objects such as nails or spikes that could pierce the soles or uppers of ordinary shoes. Exposure to molten metal that might splash on feet or legs. Working on or around hot, wet or slippery surfaces, and working when electrical hazards are present. Leggings protect the lower legs and feet from heat hazards such as molten metal or welding sparks. Safety snaps allow leggings to be removed quickly. Metatarsal guards protect the instep area from impact and compression. Made of aluminum, steel, fiber or plastic, these guards may be strapped to the outside of shoes. Toe guards fit over the toes of regular shoes to protect the toes from impact and compression hazards. They may be made of steel, aluminum or plastic. Combination foot and shin guards protect the lower legs and feet, and may be used in combination with toe guards when greater protection is needed. Safety shoes have impact-resistant toes and heat-resistant soles that protect the feet against hot work surfaces common in roofing, paving and hot metal industries. The metal insoles of some safety shoes protect against puncture wounds. Safety shoes may also be designed to be electrically conductive. To prevent the buildup of static electricity in areas with the potential for explosive atmospheres or non-conductive to protect employees from workplace electrical hazards. Hand and arm protection. If a workplace hazard assessment reveals that employees face potential injury to hands and arms that cannot be eliminated through engineering and work practice controls, employers must ensure that employees wear appropriate protection. Potential hazards include skin absorption of harmful substances, chemical or thermal burns, electrical dangers, bruises, abrasions, cuts, punctures, fractures and amputations. Protective equipment includes gloves, finger guards and arm coverings or elbow-length gloves. Types of protective gloves. Type of chemicals handled. Nature of contact, total immersion, splash, etc. Duration of contact. Area requiring protection, hand only, forearm, arm. Grip requirements, dry, wet, oily. Thermal protection. Size and comfort. Abrasion, resistance requirements. Gloves made from a wide variety of materials are designed for many types of workplace hazards. In general, gloves fall into 4 groups. Gloves made of leather, canvas or metal mesh. Fabric and coated fabric gloves. Chemical and liquid resistant gloves. Insulating rubber gloves, C 29 CFR 1910.137 and the following section on electrical protective equipment for detailed requirements on the selection, use and care of insulating rubber gloves. Leather, canvas or metal mesh gloves. Sturdy gloves made from metal mesh, leather or canvas provide protection against cuts and burns. Leather or canvas gloves also protect against sustained heat. Leather gloves protect against sparks, moderate heat, blows, chips and rough objects. Aluminized gloves provide reflective and insulating protection against heat and require an insert made of synthetic materials to protect against heat and cold. Aramid fiber gloves protect against heat and cold, are cut and abrasive resistant and wear well. Synthetic gloves of various materials offer protection against heat and cold, are cut and abrasive resistant and may withstand some diluted acids. These materials do not stand up against alkalis and solvents.
Please give comment and suggestions.
Thank you.
Subscribe our YouTube channel and hit the bell icon for more updates. Thank for visit our channel. See you next class.
Thank you.